Good morning, everyone. My name is Pierre Zhao. Today, I will present my project's RAG for open domain medical questions answering over a custom medical corpus. The main idea of this project is to build a medical question answering system, which does not only depending on the language model's memory. Instead, it will first retrieve the trusted medical documents, then generates the answer based on those documents. So this project uses a RAG approach. It takes users' medical questions as inputs, then it searches, MedlinePlus documents to find the relevant medical passages. After that, it gives those passages to a language model, then asks the model to generate the answer. So for evaluation, I use the MedQA from NIH, which is, contains medical question answer pairs. I also compare those two systems, a baseline FLAN-T5 model with retrieval and a RAG without retrieval actually, and a RAG system with MedlinePlus retrieval. I will show the results in later slides. The problem for this project is that large language model can generate fluent answers, but they may not generate information, that is guaranteed in a reliable source. We simply don't trust the random answers from AI generates. This is especially important in healthcare industry because, in medical use case, a fluent answer is not always enough. We need to know where the answer is coming from. For example, if someone asks about a symptom or treatment plan, the system should not just guess, right? It should use the trusted medical information. So the problem I'm trying to solve is, how can we build a medical question answering system that gives answer based on, trusted documents? I want to put a disclaimer like this. This project is not designed to diagnose patients. It's only for a POC. Okay. Now let's talk about the data source. So I use two main data sources. The first one is the MedlinePlus. The MedlinePlus provides healthcare, topics in XML file. I use those files as a trusted medical documents corpus. So in this project, MedlinePlus is the source that system search to answer questions. The second data set is the MedQA. MedQA contains medical question answer pairs from NIH. So I use these data sets for evaluation. I sampled about 1,000 MedQA examples and split them, into developments and test data. So for evaluation, I use about 50 test questions. To process the data, I parsed the XML file and kept English, healthcare topic only. I also cleaned the text by, removing some extra space and line breakers. Also, I split each document into smaller chunks, right? Because I use 140 words per chunk with 35 words of the overlap. So after chunking, I also created embedding for each chunk. Then I store those embeddings in a phase index, which allows faster similarity search. To further analyze the retrieval data, I investigated, further for the question type. We can see that the largest category is information questions. These are the general questions asking about, disease or conditions. Next common categories or next common things are the symptoms and treatments. These are also very important for medical question answering as well. One important observation from this chart, is the question type is not balanced. Some question types have many examples, but while some others have very few. So that matters because model evaluation can be affected by this dataset distribution. If most questions are information, symptoms, or treatment questions, then the overall performance may reflect those categories more than this rare use case. Next is the RAG architecture. Okay, so here's the overall flow of the RAG architecture. First of all, the user entered a medical questions. The system converts the question into an embedding. Then the phase search the MedlinePlus chunk. Embedding to find the most relevant passages. Those passages are to be added as a prompt, right? Then the 25 generates an answer based on the prompts and also retrieving the passage as a context. And finally, the system shows the generated answer and retrieved resources. So I put a rule that you always retrieve first, then generates. Okay, so that'll make sure it's always referring to the data source. Methodologies and models. So here's the detailed description of the model. For the embedding model, I use the sentence transformer, all mini LM L6v2. So this model converts the text into vector embedding. For vector search, I used phase, right? Just mentioned it before. It finds the most similar documents chunks for user questions. For answering, answer generations, I use Google 25 base. So, well, overall, the prompt tells the model to answer only, using the provided MedlinePlus context. It also tells the model not to make any, diagnosis or not invent any facts. Here, I want to do a quick demo. So, let's go to the Google Colab. Okay, run this. So for this demo, I will use the input cells in Google Colab. The user now can type in the questions. Just for example, let's see, what are the common symptoms for high blood pressure, right? Okay, let's see. Okay, just paste it here. It will be spin a couple seconds. But overall, I think the system will retrieve the top 5, MedlinePlus passages. Then the model will generate answers based on those passages. Yeah, here we go. So yeah, so first of all, for the outputs, we'll give the user questions. Then the RAG will generate answers based on the research, the passages, and also the use as a prompt to put into the language model. The outputs include questions, right? The generated answer and the source titles here, and also URLs, similarity scores. This one, it goes lower. That's 0.499. And also, a passage for preview. We can always preview what's the passage. Okay. All right, let's go back to my slides because I want to show some evaluations charts. So here's the mean evaluation results here. If we just look at the the root score for RAG model and also baseline models, which is using a flat T5 without any retrieval, the RAG system did not beat the baseline on Rouge, I think. Well, I think it makes sense because the flat T5 is directly trained on the Medicube 8 data, so that output should be closer to what it should be, right, on wording perspective. But the RAG is we forced it to based on another data sets to retrieve the first, then generates. So the wording may be different than the Medicube 8 wordings. But I actually reviewed all the 50 answers from RAG. Actually, all the answers are making sense, and their meanings are almost exactly the same as the baseline model, just worded differently. Also, I want to mention that the grounding score was very strong. The average grounding score is 0.80, 0.826. That means for most of the questions we can just retrieve a reliable answer from the reference. The retrieval results were also strong. Hits 1 at about 64. Hits 3 about 0.86. Then when hitting 5, we got 0.9 as a score. This means that when the system retrieves 5 passages, it usually found at least one relevant passage, which is very good. Here's some discussions. To summarize, this project's success is we successfully built a working, medical RAG prototypes. I think that works well with, what works well was the retrieval system. Because first of all, we used a reliable data source. Also, the face was able to find relevant MedlinePlus passages for, many questions. The grounding scores are also very strong, which means, the generated answer were closely connected to the retrieved context. What did not work well was I think still the Rouge. The RAG system did not outperform the baseline on Rouge, which is I think it's likely because the MedQA reference answers and MedQ+ passages may have different wordings. But definitely this is something we can improve in the future. Yeah, there are some possible future improvements. So first of all, we could use a larger or medical specific generation models. Right now we're just using a Plenty 5. Second, I think we could just use a cranker, re-ranker after the phase retrieval. Also, I could expand the corpus beyond MedlinePlus to include more like NIH resource, which giving more reliable data source to reference. But overall, I think the most important lesson I learned from this, healthcare, from this project is that in healthcare AI, actually, source grounding and transparency are very important. So a model answer, it should not only sounds good or fluent, right? It should connect to the, trusted evidence. So this project shows that, RAG is a practical way to move forward with that goal. I'm happy to answer any questions. Please feel free to reach out. Thank you.